Hey y'all, in this video I'm going to slowly start wading my way into the subject of 3D carving in VCarve Pro. Now all of this will apply to VCarve Desktop, VCarve Pro, and Aspire. Speaking of which, I've made it no secret that I run VCarve Pro. I do not have Aspire. That's why I'm going to focus on 3D carving and not 3D modeling. As most of you already know, VCarve is not 3D modeling software. Aspire is Vectric's 3D modeling software. So I can carve 3D files, but I cannot create them, and my ability to edit them is very limited. Before we dive headfirst into a project, I wanted to take a few minutes to talk about what a 3D model is, and that might kind of help you to better understand some of the settings that we're going to apply here in the VCarve software. So if you saw my previous video on the difference between vector graphics and raster graphics, titled CNC for Beginners, What is a Vector? And I'll put a link in a card up here up above. If you saw that video, you'll remember that raster graphics are made up of a grid of pixels or picture elements, and each pixel is assigned a color. It's much the same way with 3D models, except they're not made up of pixels. They're made up of points, which are known as voxels. Voxel meaning a volume picture element. Think of it as a series of cubes. Each voxel or pixel is a series of cubes that have a volume but are not assigned a location in 3D space. What we need to do to assign that location in 3D space to make sure that the surface of the model is created, is we need to adjust the elevation of each one of these voxels here. Now, again, I can't do that in VCarve. That is done in Aspire. Probably the best representation of how this works is one of these little pin art toys that you see. Imagine each one of these little dots on the end of these rods is a voxel. They all have a volume and they all have a place in 3D space. And when you press your hand up against the back of this, you see how it forms the shape of a person's hand, the different elevations. This is how 3D models are created. And in fact, if you get into a 3D model and zoom in real close, you can actually see, when there's no textures applied to it, you can actually see each one of these little voxels along with their connecting rays, which make up the surface of the 3D model. Now, how big these voxels are is dependent on a couple of things. Number one, the size of the 3D model you're going to be attempting to carve, as well as the modeling resolution. And that's why I took this side trip here, because we're going to get into modeling resolution. And we'll do that right now. We'll go into the Vectric software, and of course, when we're going to start a new file, we'll have to come over here, create a new file, go into Job Setup. The job we're going to cut is a single-sided job. I'm going to just use the standard width of 12 inches in X and a height of 12 inches in Y. My material is going to be 3/4 of an inch nominal. I'm going to set my Z0 to the material surface, my XY datum position in the center for layout purposes. When I go to cut to calculate the toolpaths, I will change this to the lower left because that's where I set my X, Y, 0 outside of my CNC. Now is when we get down here into modeling resolution. If you look here, we're set at the standard modeling resolution. Now, this has nothing really to do with the display resolution. This isn't your monitor's resolution. This is physically the number of points or voxels VCarve is going to base this model off of. And you can see right here in the standard fastest resolution, it's going to break that model down into 1 million points. If it's a relatively small model, say something less than 1.5 inches in diameter, that may be enough. Then again, it may not be. And again, this is what the model is going to be based on, not just the display out here. And I also need to throw a caution here. This only affects 3D models. This has nothing to do with V-carving, profiles, pocketing, anything else. This only affects 3D models. We can select higher resolutions by clicking this drop-down menu. By switching over to high, we have 2 million points that model will be based on. And the time it's going to take to calculate these toolpaths will be 3 times slower than standard resolution. Then we come down here, we have very high, which bases the model off of 4 million points, which is 7 times slower than the standard modeling resolution. Now, something that's built into VCarve that a lot of people don't know about is if you have a very highly detailed model with real intricate levels of detail, there are 2 more modeling resolutions at your disposal. And the way you get to those, we'll go ahead and we'll hit cancel. The way you get to those is you come up here to create a new file, but hold down the shift key. Then click create a new file. Now none of my settings up here changed, everything is the same, but when I come down here to modeling resolution, I now have extremely high, which is 20 times slower. That is calculated based on 8 million points. And the maximum, which is 50 times slower and is based on 16 million points. Now, let me warn you about just saying, oh, well, then I'll just use maximum all the time. When they say 50 times slower, they mean it. A lot of this is going to depend on how big your file is, meaning the physical size of the 3D model, how big your job size is, and how intricately detailed the model is. If you're doing just a dish or a dome, this is overkill. It's not really necessary. But if you're doing something that has a high level of detail in it, this may be for you. Just be warned that when we go to calculate toolpaths, the toolpath calculation time is going to be 50 times slower than the standard resolution, and the amount of time it's going to take to preview that toolpath is going to be 50 times slower than with standard resolution. Now, I'm going to back it down a little bit here to extremely high. We'll run 8 million points, and I'll use that to demonstrate this first model. So we'll go ahead and accept all of these here and click OK. Probably the easiest way to introduce yourself to 3D modeling is by using the Clipart that comes with the Vectric software. So when I come down here and I click the Clipart tab, we transfer over here to the Clipart library window. Up here we have the library folders that are available to us. Down here we will have a list of files. It's broken up into two sections. This section, Clipart, I have downloaded all of the Clipart that's available to me through my V & Company portfolio. And it's broken up into various different categories. Down here we have design and make. Those of you who have downloaded files from design and make, this is where you'll find them within your Clipart library. So we go back up here to the Clipart library because all of us should have this. And we'll go ahead and we'll choose a simple dome/dish. You can see when I clicked on domes and dishes, it opened up these 10 files right here. And I have a selection of just dome shapes and kind of almost like platform shapes here. These will work for domes and dishes. The difference between these 4 up here at the top, which is what I'll focus on this time, we have here dome dish 30, 45, 60, and 90. Basically what these are these are carved at different angles. 30-degree angle, 45-degree angle, 60-degree angle, and 90-degree angle. This would be the deepest dome of the dome or dish of the 4, and this would be the shallowest. I'm going to start with the 30-degree. There's a couple of different ways of importing this into our drawing out here. One, I can drag it and drop it out here anywhere on the screen. Or if I want to place it in the center of my material, I can just double click it and it imports directly into the center of my screen. And you'll notice that when it imports, it is in move and transform mode so that we can size this model. I'll come back over here to my drawing tab because I'm through with my Clipart tab. And I'm going to size this dish. Now, I can do that by either using these grab handles out here on the corner, just like any other vector or bitmap image that I'm importing. Or I can use set selected object size over here under transform objects to set a specific size. Now in this case I want to go with a 10-inch dish. So I'll go ahead and select either one. It doesn't matter because I have link XY checked, and I'll enter 10 as my width in X. Click apply and it scales our 3D model to that size. Now we'll close and then take a look over here in the 3D view. If we look at our 3D view now, what we have is we have a dome that's rising up above the surface of our material. Well, I don't want to carve that into the surface of the material. I want to carve a dish into the surface of the material. So the way we'll fix that is we'll come down here to the modeling tab. Click on the modeling tab. We now see that we have a level and a component inside that level. We have our model on level 1. We can see by this icon right here that this is set, the combine mode set for this model is pointed upwards. We need to change that to pointed downwards. We want to carve this as a dish, not as a dome. So the way we'll do that, we have a couple of ways of doing that. One is we can come up here and we can click this wrench icon to change the properties of this model, or we can double click on the name and enter the properties for this model. when we look up here, we have the name of the model, and we have 5 different ways of combining this model with other components, other models that we may bring in and try to put down inside this dish. But first of all, what we want to do is we want to make this a dish instead of a dome. So I want to move this from a dome, carving away the rest of the material and leaving this behind. I want to make this a dish. Now you see we automatically updated. So now when I flip this around, I have this dish shape. You'll see we have kind of a surface on top of it that doesn't really make a lot of sense. And we have this sharp vertical edge. What VCarve has done is it has stacked up all these voxels that are needed to represent this dish and given them a place in 3D space that makes the shape. Since this is the outer boundary of that shape, we have this sharp edge right here. VCarve has no real reference to figure out where to place this shape. We'll get into that in just a second, and it will eliminate this sharp vertical edge here. Okay, as it sits right now, our shape height is 0.6651 inches. That means from the top surface, it's going to cut 0.6651 deep. Well, I don't want it to cut that deep. I only want it to go about ½ an inch deep at the max. So we'll change that to 0.5. And we saw how it calculated down here. And now we see we have a slightly thinner profile here. Now, I'm going to go ahead and accept these settings as they are, and we'll close that file. Now, again, we still have no real reference as to where this model is going to be placed in our material. To do that, we need to add a zero plane. And a zero plane is just a reference plane that, number one, makes this model make a little more sense to us. And it's also a plane that the software can reference from so that this sharp edge isn't modeled, isn't created. We'll come up here and we'll click Add a Plane Component with 0 height covering the model. And there we have a piece of material with that model ready to carve into it. Now you'll see the model has a pink color to it. And that's letting you know that it is active. And that's what we are going to be carving. Now if you take a look down here in this area right here, when I have my mouse cursor over there, I have my X, Y, and Z readouts. As I get over here and start going down into the bottom of this model, we can see that my Z is going negative. And the deepest point it will get to, not quite 0.5, but very, very close. So, what we've done so far, we've imported this dish into the model, or into our workspace. We've set the dish. We've set the dish's depth. We've told it, VCarve, that we want to carve the dish out of the center of our material rather than carve away and leave a dome behind. Then we added our zero plane to the top to give VCarve a little bit of a reference point as to where to start carving this model. Now, this being the first video in this series, we're going to go ahead and carve this model or simulate the carving of this model just as is. So to do that, go back over into my drawing tab. I didn't need to do that. We'll go over into our toolpaths tab. I'll jump back into my 2D view to make sure that we have the model selected. And I'm going to select a 3D roughing toolpath. Now, before I do this, let me just say a lot of people don't use a roughing toolpath. I do use a roughing toolpath for a couple of reasons, and I'll get into those as we move along here. But I'm going to go ahead and create a roughing toolpath. I'm going to use a ball nose bit to rough this out, a 1/4 inch ball nose bit. And I'm going to set my step over to, I'm going to bring that down to about 20%. I'm going to leave everything else as it is because I can increase my feed rates on the fly outside as I see how this model is cutting. Click OK. I want to machine only the model boundary. I just want to machine this dish. I don't want to machine anything else out here. I will leave a machining allowance of 0.25 inches. What this means is the bit is going to cut 25 thousandths of an inch shallow. It's not going to cut all the way to the finished depth. It's going to leave 25 thousandths of an inch of material for the finishing toolpath to come clean up. That's all the way around the whole model. Something I forgot to set, which I'm going to set now, is I'm going to set a boundary offset of the diameter of my ball nose bit, so 0.25. What this will do is when the bit comes up to the edge of the model, it's going to go beyond that edge, the diameter of the bit, just so I don't have a harsh ridge there. It'll kind of move its way over, ease its way over the edge to blend in that top portion there. I'm going to use a Z-level strategy, rastering on Y. I'm not going to worry about plunging in my ramping in my plunge moves. I'll just go ahead and calculate it with the same name. And we'll calculate. Now, there you see, rastering along Y, what path that tool is going to take. If I wanted to change that, I can come back and raster along X. That will make my tool go side to side instead of front to rear. Personally, I don't think it matters in this case. What I would tend to do for this particular toolpath is match my raster direction with the grain of the material. So actually I shouldn't have changed it because I see now my sample material is running up and down. I should raster it in Y. So we'll calculate, and there we go. Now I'll go ahead and I'll preview this toolpath. And we can see that our roughing toolpath came in and carved away the majority of the material, the bulk of the material. Now, a minute ago I said some people don't bother with a roughing toolpath. I use a roughing toolpath because I do not have any tapered ball nose bits for 3D carving. If you do have tapered ball nose bits, you may choose not to do a roughing toolpath. That's up to you. But I don't have any. I'm using standard ball nose bits. And on my standard ball nose bits, even on the smaller ones especially, the cutting depth of that bit, on some of them it's 1/2 inch, On some of them it's only 1/4 of an inch. So I need to remove the bulk of this material with a roughing pass, leaving only that 25 thousandths, so I know that my bit isn't trying to carve away too deep into this material. I know that the edge of the bit, the shaft of the bit where there's no cutting edge, is not going to hit uncarved material. That's why I do a roughing toolpath. Again, if you have a tapered ball nose, you may decide you don't need to do that. I have to do that. So, there's our roughing toolpath. And if we bring our cursor down here and look at our X, Y, and Z display down here, we can see that we have gone, a little more than 0.375 deep. And we can come over here and just hover our cursor over the name of this toolpath, and we see that the max depth, the second line from the bottom, says we've cut to a max depth of 0.375 inches. Okay, that's great. Let's go ahead and do a straight standard Z view. Now we can move on to our 3D finishing toolpath. So I can close my preview. I can see in my 3D view that the model is selected. I'll just confirm that in the 2D view. Yes, it is selected. We'll come over here to the 3D finishing toolpath. Now, I want to use, because this is such a plain model, I can use a pretty large bit, so my machining time will be less. So I'll come up here and I'll select a 1/4 inch ball nose from my list. My step over right now is 20%. I will change that in a minute. I'm going to leave everything else the way it is. I can speed up my feed rate outside on the machine. So we'll go ahead and accept that. Then I'm going to immediately come back up here to edit. And because this is a finishing toolpath, I want to reduce my step over to eliminate the ridges in between the passes of the bit. I find that most cases for 3D carving, I can go somewhere around 8 or 9%. And it will leave a pretty good finish. It'll remove most of those ridges. So I'm going to try 9% and see how it looks in the preview. Now what this means is when the bit is finished making a pass, it's going to step over 9% of its cutting diameter and make the next pass. And we can see that's only 22.5 thou on a 1/4 inch bit. So we'll go ahead and say OK. I'm not going to use a boundary offset this time. I'm going to raster with a raster angle of 0 degrees, meaning it's going to run side to side. And I'm just going to go ahead and let it be called the 3D Finish 2. And we'll calculate the finishing toolpath. And now you want to talk about some slow calculating times. This is when it is slow. The roughing wasn't that bad. This is actually going fairly quickly because I'm using such a large bit. If I were using a 1/8 inch bit, it would be a lot slower than this. Imagine if I was using my 3/64 bit. Now I'm running this in real time just to show you how slow some of these calculations can be when we're using high modeling resolution. Almost finished. And there we go. We can see that even though I have selected the model boundary, it's going to carve the entire surface of our material. So I'll go ahead and go into my preview window and we'll preview that toolpath. Now we see how long the simulation will take. I guess I could have gotten rid of the animation. I can get rid of the animation for the tool to kind of speed that up a little bit. But we see how much longer it takes to simulate that toolpath because we use such high modeling resolution. We're only up to 35% of the simulation being run. And again, I'm leaving this go in real time so you can kind of get a feel for how much longer it's going to take to calculate and preview a toolpath when you're running higher modeling resolutions. I still didn't use the highest. I used very high, which is running 20 times slower than if I were to use standard. Very high, 20 times slower, is still a bit of overkill for this particular project. It's not a detailed model. It would be very easy to get down inside this dish with a soft sanding sponge to clean up the any tooling marks left behind by the bit. But just to demonstrate how slow this can actually be, I went ahead and I used a higher resolution. We're just to about 78% finished. It won't be much longer. Okay, and there is our finished model. Now we can kind of turn it here and get a look at how that's going to turn out. We have a nice smooth transition here. Maybe maple is not the best wood. Let me go for a medium color. See if that gives us a little bit more contrast. But we can see we've got a nice smooth transition from where that dish comes up and meets this top surface. There are no ridges. There are no funny angles or anything like that. Now again, we can kind of bring the cursor down in here, and we see it kind of goes to about 4.4996997. I can hover my cursor over this. Yeah, it runs to not quite a half an inch deep. 1/10 of a thou shy. But I get a nice smooth looking dish shape. That would look very, very nice. Just as a little display platter. Some fruit in here sitting on the counter. Someone might like it. So, I know this was a very, very simple carve. I know this was a very simple project. But this was just a kind of breaking it in gently and introducing 3D carving in VCarve so that we can kind of get started. In future videos, we will go a little bit more complex. We'll add models to these dishes. We'll use more of the Clipart here in the library. Maybe we'll choose something like the cantering horse. Maybe we'll choose an eagle. I don't know yet. But we'll get into a little bit more complex modeling. Then we'll get into importing 3D models from other programs. So I'm going to go ahead and close this one out. If you got anything out of this video at all, I'd appreciate a thumbs up down below. And if you'd like to follow along with my further CNC adventures or my further laser adventures, I do hope you'll subscribe to my channel. But as usual, whether you subscribe to my channel or not, thank you very much for taking the time to watch, and y'all take care.